So I am really excited though to present our guest and a Globe partner from Colorado, Jonathan. And I'm really excited about this curriculum unit and hearing about what you've been doing with Fire and Globe and this offering that you have for teachers moving forward. So I'm gonna hand it over to you. I believe you can share your screen if you'd like to do that. And if you want to do your own introduction and share your favorite class in high school, we would love to hear that.
Great. Thanks, Jen. And hi, everyone. Thanks for joining. I'm Jon Griffith, Globe partner at the University of Colorado Boulder. Originally, I'm from Central Vermont and just bought a house back there. So going to be moving back east here shortly. And my favorite class was metals tech. I loved welding and grew up doing a lot of skiing. So would weld rails together that I would hit in the backyard. So pretty fun to think about that. But yeah, my path, I spent the last 10 years largely in Flagstaff, Arizona, as a geologist, more specifically a paleolimnologist. So spent a lot of time in the Arctic coring lakes and studying lake sediment to better understand climate and environmental change. I really enjoyed teaching lab courses at the university. And so found that as kind of my passion and hopped into education, was a middle school science teacher for a number of years, and then chased my girlfriend to Denver, Colorado, and was able to secure this position as a curriculum developer, largely focused on the Mosaic Arctic Research Expedition. So primarily the last 2 years, I've been in charge of developing resources related to the Mosaic Arctic Expedition and connecting classrooms to that. And as you all know, you wear a lot of different hats in education. And so the person who I took over for was a Globe partner. I became the Globe partner. And more or less the story is that the person that I replaced was trying to develop a fire fuel protocol, and there were some issues related to that. And so when I came in, it was kind of like, what do you want to do? And so I remember meeting Petter at AGU in 2019 and speaking with Tony Murphy. And I said, I wanted to write a curriculum that provided some context for a Globe protocol. Because as a former teacher, that was always something that I wanted. Was you can't just have, here's a protocol, go use it. I feel like it's going to be used more readily if there's a reason to use it. And so this curriculum is my attempt to provide a reason to use the Globe Observer app, more specifically the land cover protocol. And had the privilege of going through it with Todd a few months ago, and working on some revisions now. And we're excited to run a bunch of workshops this summer focused on the curriculum. And so, excited to get the chance to share it with you all today. And should you be interested, continue to work with you, or, help spread the word so we can get more people using the Globe Observer app and using this particular curriculum. So I'm going to share my screen, dive over this unit that we've called the Future of Forests. And essentially, it is an opportunity here to study patterns of ecological succession in fire-affected landscapes. So how are those changing in the face of changing climate conditions? And so I wanted to just, before we dive into the curriculum, and we're going to do some interactive stuff, I'll dive into particular lessons, but I really wanted you all to kind of be familiar with the instructional framework here. And so I was trained to write curriculum following a model-based inquiry approach, which is a framework designed around the construction, revision, and testing of conceptual models by groups of students as they seek to understand and explain natural phenomena. And what I mean by phenomena are observable events. And so for this particular unit, there in all of these model-based inquiry units, there's an anchoring phenomena or observable event. And so everything that we do relates back to that observable event. Students are trying to model and explain that. The way these units starts, and what we'll start with today, is this eliciting of ideas. So when we introduce the observable event, the phenomena, we ask students, what do you think? How can you explain that? What do you observe? And we create these public records. And that way, that's kind of our diagnostic assessment. We get to know what students already know, and then we can kind of build on those ideas. By making everything public, we challenge students to learn with and from one another, kind of taking a little bit less off the teacher as the knower of everything, and putting more on the students and the co-construction of knowledge. After we elicit students' ideas, each activity, each lesson thereafter provides students with a nugget of evidence that they'll need in order to create a final explanation of that phenomena. And embedded with all of this are practices of modeling, explanation, argumentation. We make lots of public records. This really helps with coherence and allowing students to know what they're doing and why they're doing it in the context of the phenomena. And then the learning is collaborative. And so that's our goal here. And I'll show the curriculum page kind of at the end, but everything here, of course, is freely available to educators. Again, still kind of going through some of the revision process, but we've got a draft up right now. And so what we'll do right now is we're going to start with this Future of Forests unit, this first phase here of the eliciting of student ideas. So I'll kind of model how I would introduce this phenomena and engage you in this first task, and then we'll dive into a few of the lessons before we get to the globe app at the end. And so again, we're thinking about fire, a lot of 2020 being the worst fire season in the American West. So many headlines. How did the 2020 wildfire season get so extreme? 2020, an extraordinary year for fires, and we can expect more like it. Severe wildfires are burning 8 times more area in the Western United States, a study finds. If we think about California and Colorado, these Western states, we often hear a lot about wildfires impacting those areas. The top 5 largest wildfires in Colorado history, you can see the largest fire took place in 2020, the second largest in 2018. You can see the structures and deaths. And then each of the following fires took place in 2020 as well. So 4 of the top 5 largest California wildfires by burned area took place in 2020. And from those headlines, we can expect that to continue to be the case. These fires are going to be larger, more extensive. In terms of Colorado, where I live, the Cameron Peak fire in 2020 was the largest fire ever to take place here in Colorado. And actually, number 4 here, the East Troublesome fire, when I snagged this screenshot October, it was the 4th largest fire. It is now the 2nd largest fire. So if we look at this figure here, this image, 3 of the top 5 largest Colorado wildfires have occurred this year. And interestingly enough, the Cameron Peak fire, so this was the largest Colorado wildfire taking place in and around Rocky Mountain National Park. It was only 10 miles away from the 2nd largest Colorado wildfire ever in 2020. I'm sorry, that took place in 2020, the East Troublesome fire. So these fires are huge, and they're continuing to burn more and more of the landscape. And NASA satellites can track all of this. We can see these burn scars. We can see these smoke plumes. And so in the curriculum, we challenge students to use a lot of these NASA assets. I'll add this to the chat just so you can all kind of interact with it should you be interested, but I'll model what I'm playing with. And so in this case, in the unit, I'm talking a lot about the East Troublesome and the Cameron Peak fire because they're so close to one another, such large fires in Colorado. And these images here, you challenge students to, make sense of what's the red here. And you can see it's a burn scar. What's a burn scar? And to have those conversations, you can see the active burning on the edges. And so again, we're just trying to present this observable event, the fact that these fires across the West are burning larger and more extensive areas across these Western forests. This is without those colors on. And students that are not in Colorado, perhaps they're interested in some of the scars in California and other places. And so this is kind of an opportunity to inspire students to explore some of these resources for themselves and generate their own questions. Following the engaging with this interaction, we won't do it just in the interest of time. I want to show you a few other things, but there's a short 2-minute video here that really hammers home the point that these wildfires are becoming larger, and burning more of the landscape. And so in talking with some of the scientists I work with, one of the common things that they're interested in studying, and the focus of this particular unit and the driving question is, how are these landscapes going to recover after a wildfire? These fires are bigger and bigger. They're burning more of our Western forests. What happens after these forests burn? And so in the unit, we set it up in that way, try to create some engagement and interaction, some intrinsic motivation in the students. And we ask them now to collaborate. And normally what I would do in a larger workshop is I would ask the participants to come up with a list of initial ideas or explanations for this question. In the virtual world, when I facilitate these sort of workshops or lessons, I'll use Jamboard and just ask participants to add a sticky note. What's an idea that you have that could potentially answer this question? In the classroom, when I facilitate these sorts of units, I'll use butcher paper and make the students' ideas public. So this is that diagnostic assessment where we meet students where they're at and kind of can build on what they already know here. And the next phase of this is after we have students' ideas as they relate to this initial unit driving question, I encourage them to borrow or steal ideas from one another that are on these public records to create their initial conceptual models. So to take these written words that are on boards and to put them into some visual representation of their thinking. And this is something that we revisit several times throughout the unit. So we can add or subtract new concepts or new elements as we learn new things through the lessons. And so in this case, looking at some of these initial models, we're pilot testing this curriculum. It's in about 5 classrooms right now. So gathering some feedback before the next revision phase. But you can see these students they're seeing the wildfires are burning vegetation, as we might expect. You can see they're saying adding minerals and resources to the soil, which allows for those trees to grow back. So kind of the traditional secondary succession that we've all been taught. Some of this is a middle school classroom. You can see water is an element that continues to be added here. So, for me as the facilitator, as a teacher, I would kind of key in on some of the different aspects. It looks like water and it might take time, but ultimately you're going to get your tree back is what I'm seeing from these initial models. Again, these models here look like kind of traditional patterns of secondary succession is what these students are thinking. So, you can use these again as an opportunity to see where students are at and then, say, hey, we're not saying one is right, one is wrong. Perhaps there are elements of all of these things that could help us explain and answer that question. We're going to build on these ideas. And so that kind of sets the seed for each of the lessons to come. Now, if I were facilitating a longer workshop, I probably wouldn't give you the answer right away, or maybe you already know the answer. But because this is kind of just a short introduction, here's the answer. how do landscapes recover after wildfires or disturbances for that matter? And so what the research is showing is that it depends. It largely depends on what the first few years are like in terms of drought conditions after a fire. And so during wet times, when it's wet after fires, post-fire years, these traditional patterns of secondary succession are largely holding. So we have the forest, the fire, this burned landscape, and then we see those pioneer species come back, the grasses, shrubs and seedlings, and then the larger climax community comes back. However, during dry times following fires, we see these forests transitioning into grasses and shrublands. So the research is showing as we're seeing more drought conditions across the West, seedlings are having a hard time regenerating in these dry conditions. And so grasses and shrubs are coming back. They're thriving and taking over the landscape. And so kind of the sad reality of what we face out here. And it's definitely a change in terms of the way in which we may teach ecological succession. So, this can happen, but it depends largely on what those climatic conditions are. And as they're changing, so too might these patterns. And so we explore this through a number of engagements and different case studies. Now with that, again, here's the sneak peek at the answer. I wouldn't have normally done that. Normally what I would do is kind of dive into each of the lessons. So after we've presented that driving question of how do landscapes recover after a wildfire, this first lesson from Fire Comes Life students, we actually engage students and talk about the traditional secondary succession pattern. We create some story maps to walk through this secondary succession using different vocab words of pioneer species, secondary species, and the climax community. Students play a rock, paper, scissors game that's modeled after the secondary succession pattern that we just talked about. And so we're basically like, yeah, this is what happens. Trees grow back right after a fire, right? Let's test that idea in lesson 2 by conducting a survey. And it was fun to hear. I know somebody here is from the Forest Service and just happened to pop on a webinar and learn about this amazing landscape recovery, landscape monitoring system tool. And we'll go to it here in just a second. But after introducing secondary succession, we can actually test whether that works, whether these concepts work by looking at this interactive tool. And so I'll add it to the chat here in just a moment, but this is the tool that students would use, the landscape change monitoring system. And again, the reason we're using this is to test whether secondary succession actually happens the way we just talked about it in the previous lesson. And so with this particular tool, I'll just add it to the chat right now so you can engage with it and play with it while I'm talking. The first thing I like to do, because that you can do so many things with this Forest Service tool, is I'll deselect from the menu over here, fast loss year and slow loss year, just so I can kind of have a blank slate. And so again, I'm primarily looking at the Western United States. And for this example, for what I'm going to show you right now, I'm going to focus on the Colorado Springs area. But this is kind of the fun thing about this tool and this curriculum is you could use it wherever you're at. And so what I'm interested in doing, I just clicked the plus sign here to open reference data. I'm interested in looking at when these burns took place. And so if I click on burn year, I can see these different colors show up across the landscape. Again, here's Denver, here's Colorado Springs, and these colors represent a different burn years. So I'm looking at 1985 to 2020. So, we're looking over what 30, almost 40-year time period here. If I look at Colorado Springs, you could see some big fires just outside the city here. I think this fire was around 2002, some more recent. And so we can see the burn scar of this overlaid image here. And when we could kind of see too that this looks like a forest here, right? You can kind of see the trees make out the different colors. And when I deselect the burn year, you can really see that burn scar from the image. And so it suggests that the forest didn't come back after this fire. When was this fire? I'll click on the kind of, I think around 2002. So it's been about 20 years and we've got nothing. And if I look a little bit north in Buffalo Creek again, you can see that scar really clearly. And that fire looks like it might even be closer to 1985. So there we're looking at 30, 40 years. And so by starting with this example, we can start to ask students, well, do all forests recover the same way? Do we see that secondary succession pattern playing out when we use this tool? And of course, the answer is no. And so that generates the question that for our next lesson, which is why? Why don't we see all forests recovering the same way? Are there different factors that might be affecting this? And so I also want to preface by saying that this tool is ridiculous, super cool. I'm not even going to pretend to know all of the different things that you can do with it. You can look at burn severity, burn count. There's tools where you can measure the distance between fires, the area. I'm focused on this one aspect of it. But I would encourage you, if you're interested, you might have to dig in a little bit more. My knowledge is pretty limited, largely from this 1-hour webinar that I participated in. But in this case, again, serving the function of planting that seed, all forests don't recover the same way. Why is that? And from there, we talk about, what do plants need? They need sunlight, they need soil, they need nutrients, they need water. And so we transition in and talking about how NASA satellites measure water from space. They measure soil moisture from space. So we look at the interactive and allow teachers and students to engage with this Earth Now satellite viewer. We focus on the GRACE and the SMAP satellites, those that measure soil moisture conditions. And so allows students to see these satellites, see where these data sets are coming from. It allows students to actually look at data in nearly real time and get a sense of what soil moisture conditions are across the globe and in their area in particular. I'll just add this. I forgot, I wanted to add this to the chat in case anybody wants to play around with this tool. But really, again, one of the things I found is you can't just give students data or visuals and say, hey, what is this? It really helps to connect the students to the instruments where the data sets and the visuals are coming from. And so we explore SMAP and GRACE through this tool, and then you can go and get different measurements from the GRACE satellite and explore soil moisture conditions in your area. And you can see across the West, soil moisture conditions are really low. Lots of drought-like conditions across the West. And so if we go back and think of it in terms of like what's going on in this unit, we talked about secondary succession patterns. We established that doesn't really hold true all the time. And now we're figuring out, well, why is it that some forests might grow back and others might not? And we start to think about water and changing soil moisture conditions. We look at some case study data to show that the rise in temperature increases evapotranspiration rates across the West. And so as temperatures rise and we lose more water, we see these drought-like conditions, and that might affect the ability of different forests to regenerate, to recover. And then we look at some different case studies from Idaho, Colorado, Montana, and California and revisit these patterns of ecological succession. And basically what we see during these drought-like conditions, seedlings are having a hard time recovering after wildfires. And we're seeing more of a transition into grassland, shrublands after wildfires. And so again, the idea here is through these different tasks, these different lessons, students are gathering evidence that they can then apply into a final model or explanation. So in this case, we want to be clear that everything's dynamic. There's not, and in these ecosystems, it's not like, oh, every landscape that's been fire affected is going to transition to a grassland or shrubland. That's not true. Sometimes an area might see increased moisture after a fire, and that might help these trees regenerate, these seedlings regenerate. And we might see those traditional patterns of secondary succession play out. However, the projections for soil moisture across the West, which we include in this curriculum, another NASA product, show soil moisture conditions are going to continue to get drier and drier. And so we might expect not only these fires to be larger, burning more of the landscape, but these landscapes to transition into different types of landscapes. And so that's what we're expecting. And here's kind of an example that I put together to help educators kind of know what I was thinking when I wrote this. And so again, kind of the traditional pattern of secondary succession, and then the drier conditions, which are projected to be more common, to look something like this, where we don't see these seedlings coming back and we see this transition. So again, trying to take these lessons and these different bits of evidence and display them visually to explain the driving question. And that brings us to the NASA GLOBE program. And so through that lens, like, we need to do a number of different things. We need to gather more information about the landscapes across the West, not only after fires, but also before fires. We need to know what was there. Otherwise, we're going to have a hard time figuring out what comes back and what these patterns look like. And so through this lens of we need help in terms of monitoring the regeneration of landscapes following disturbances, whether that's a fire or urbanization or a flood. We need to continue to gather these land cover observations so we can assess how they change. And so it's through that lens that we challenge classrooms to download that Globe Observer app and to use the land cover protocol to, again, make observations about the landscape around them. And even better would be to do it once a month, or to have a teacher do it every year, so we can start to gather more comprehensive data sets that track landscape change. Included also in this task of going out and gathering observations using the protocol, I challenge teachers to use something I used to do when I was an environmental ed facilitator, which is to create a landscape quilt. And so not only would I have them make observations with the land cover app, but I have students go out and I really like to have students just sit alone in silence. They don't really get to do that, and make observations of the landscape around them. Students often say, I don't like drawing, I'm not an artist, I can't do this. And so with the landscape quilt, we kind of break it down. This is one that I put together where we pretend the student is the X in the middle. And then rather than actually draw things, you can make symbols or add shapes that represent different vegetation types or urbanization. You can kind of start to group things and start to identify patterns across the landscape. And so I thought that this would be a nice activity that would go with the land cover protocol as a way to get students outside, not only making observations with a piece of technology, but giving them an opportunity to also make their own observations and present them artistically. And then as a class, you can talk about different patterns that you might see over here versus over here. So a nice way to try to bring all of these things together. So again, the wildfire piece, that's a disturbance. It shows changing patterns in ecological succession. The land cover app, an opportunity to continue to monitor land cover changes, whether it's before or after a disturbance in a particular area. And then this landscape quilt, a nice kind of artistic piece that brings in an opportunity for students to to make observations about the patterns and why they see what they see, where they see it. So with that, I'm going to end here. I want to just say I'll add a link to the chat here that has a number of the resources that I just presented today. But I'm going to facilitate 2 workshops this summer. They're free. You get 10 PD hours and the option to purchase a credit from CU Boulder. So that would be really helpful. We've got about 65 registered. I'm going to go up to 100. We're hoping to sell these out. So your help in terms of promoting these would be really, really great. And yeah, I wanted to do a couple of things real quick. One, I want to add this link to the chat, which is all the resources that I just went over. So my email, our Twitter handle, you can find the whole curriculum here, the slide deck, Eventbrites for the 2 workshops I just mentioned, some of the resources that I added to the chat, those interactives, as well as some more information about model-based inquiry, this instructional framework, if you're interested. Also doing a couple other workshops related to the work I'm doing for Mosaic. So if you like this particular instructional framework and have educators that you think would find that worthwhile, send them that way or my way, and I'd be happy to work with them. Final thing, I'll add this to the chat as well. This is the full curriculum page. So we've got pretty comprehensive unit summaries and storyline documents, as well as the individual lessons. So in this case, what teachers are going to get, some background information. I break up each lesson into parts and how long they'll take. The teachers are going to get their unit and lesson driving questions and their connection to different NGSS standards, materials, slide decks, answer keys, student worksheets, and then I describe each part below, trying to keep things as succinct as possible. So that is obviously a ridiculous amount of stuff to throw at you in 30 minutes. And if I had more time, I would definitely dive in and we'd really like the workshops. We're going to use these interactives and you'll have 20 minutes to use it. Think about how you use it in your classroom, talk to people in breakout rooms, talk to me. But in this space, this was kind of just throw it all at you, and hopefully the sales pitch works and people will want to work with me and work with teachers to get this out.